State University, and he obtained his PhD from the University of Kansas in 1995. A physical geographer, Professor Arbogast specializes in the formation of American landscapes, including the Great Plains and dunes of the Great Lake region. His textbook, Discovering Physical Geography, is used at over 60 colleges and universities around the country. And I, as an undergraduate, have in fact read Discovering Geography by Dr. Alan Arbogast. So I can personally attest to the brilliance and textbook
boy,
writing.
you're laying it on thick, Tyler.
So without much further ado, go ahead, Dr. Arbogast.
Wow, that's the best introduction I've ever had. All right, let's see if I can. Well, I want to thank everyone for showing up today for this virtual presentation. Strange times we're in and all of that, but yet we're still managing to communicate and share stories and things with each other and virtually, but still, somehow effectively. I want to thank John and Tyler for inviting me to participate in this. Tyler and I have worked together. I kind of served as a mentor for him. Was that 2 years ago?
I started 2 years ago, and then last year as well.
Yeah, and John and I are mates and worked with in the UK with one of his groups. I guess that was in 2017, I'm guessing. And boy, that was a fantastic experience with the scholars over there. And so there's a legacy that we're building on here today. So what I'm going to talk about is the geomorphology and the evolution of Lake Michigan coastal dunes. And Tyler, you're in charge of the chat. Is that right? Yeah. Okay.
Correct. Yeah, I'll manage that.
I'm in a geography department. My PhD is in geography, but I could easily be in a geology program too, because much of my work is geological. But I'm interested in the geographical side of things, about just where things are, and in this case, where are the dunes, why they happen to be where they're located, and how they may differ from one another in various spaces. The term geomorphology refers to the evolution of the landscape. The form of the geo is earth, and morphology is the shape. And geomorphologists look at streams, they look at glaciers, they look at deserts, alpine systems, all of that. I happen to look at sand dunes. When I do start my presentations, I always want to start with just how great our dunes are in Michigan. I've had the good fortune to see coastal dunes in a variety of places globally. Here's kind of a snapshot. This makes John yearn for home. I'm sure this is kind of a gray, bleak sky. He's feeling good right now, thinking about that. Irish Sea over on the right, that's this is just north of Liverpool on the Sefton coast. Here is on the southwestern coast of Australia near Perth, and great coastal dune landscape there. Anybody would want to go to Australia and see it's an exotic place, and dunes in Australia sound really exotic, so why not? This is the North Island of New Zealand, north of Auckland, a fantastic dune field that I was on field trip with a group of students long ago. Jen happened to be on that, and I distinctly, the tracks that you can see in front there are the ATV that shot up the dune face with my wife hanging on at the back. Just a great landscape. And then here are ours. This is near Holland. That's not Holland, the Netherlands, that's Holland, Michigan. And just a magnificent dunescape. Rivals anything that you would find anyplace else on the planet, right here in the Midwest. And, we tend to be, kind of demure about how great we are, but this landscape is a fantastic one and needs to be celebrated for that reason. So the geographer in me is why do we have such great dunes in Michigan? What's going on here? Well, here's obviously this is a satellite image of the Great Lakes, the best and biggest of the sand dunes that you find in the region are all along the west coast of lower Michigan. There are also nice dunes on the south side of Lake Superior, north coast of the UP. There's some nice dunes over on the Wisconsin side, even some over on the Ontario side, but they're not as large, as massive, nor do they extend for the same geographical length as they do on the west coast of Lower Michigan. And geographer wants to know, well, okay, where are they? And then why are they there? Well, for us, the east side of Lake Michigan is on the downstream side of westerly winds. And those prevailing westerlies, which we have here in the Midwest, it's the same wind system that is feeding dunes in the UK and Northern Europe, is moving air across Lake Michigan over onto the lower peninsula of Michigan. There's a long fetch across Lake Michigan. What that means is that the air can flow cleanly across the lake. There are no obstructions in the way. Once the air starts flowing over the lake, then by the time it hits the lake shore, which is the first thing that it runs into, it's moving at full force and can easily move sand. And then third, Michigan is a big sandbox from the last ice age. The glaciers that covered Michigan from, say, 25,000 to 10,000 years ago, this part of Michigan here in Lansing was under ice for probably 9,000 years, as recently as 16,000 years ago, deposited copious amounts of sand, copious. And that is the raw material for which dunes can be constructed. So these factors all working together result in magnificent dunes. Now, there's also what you see on the right-hand side here. That is a high-resolution LiDAR airborne radar image of Michigan's dunes. It's a very duney sort of looking landscape that you see there. If I saw that any place on Earth, I'd go, those are sand dunes. You see nice parabolic forms. If you see this kind of shape that I'm outlining here with my fingers, I started pointing at it on my image like you would be able to see what I was pointing at. But if you see this form here, those are parabolas that are dunes, individual dunes. And they indicate that the direction that the wind was blowing at the time that the dune was forming. Like for this one, for example, air was flowing in this direction. And most of the dunes along the lake shore are that way. There's a geographical variation in how you can think about the dunes between the northern part of Michigan and the southern part. The dashed line that you see here, this so-called hinge line, is the line where north of that, the landscape is still rebounding from the weight of glacial unloading from the last ice age, which in the UP is 10,000 years ago. That's when ice finally left. And to give you a sense of things, Sault Ste. Marie is still, 10,000 years later, is still rebounding on the order of about 10 centimeters a century, still. That's why the locks are there. Lake Superior, Lake Huron, and Lake Michigan all used to be on the same water plane. Well, Lake Superior has elevated above those two water bodies because of the uplift of the landscape there because of glacial unloading. South of that line, south of this line here, the area that's highlighted as yellow, that landscape is stable, or even maybe slightly subsiding, maybe. And so the dunes there tend to line the shore for long ways. I mean, like many, many miles. They're humongous things. And the image that you see on the right-hand side is a good representation of that. So that's the part of the state that I first started working in because the dunes there are magnificent. I mean, they're just, if you've been to Holland State Park or Muskegon or Nordhaus Dunes or any of those places, you know what I'm talking about. Now, north of the hinge line, up here, that landscape's still rebounding. And you can see evidence of that. And this is one of the fun things about geography, is that you can often see these things on the landscape. When you're driving around in the northern UP, or the northern part of Lower Michigan, along the shoreline, you can see these notches like so, and they line the shoreline everywhere up there. That's essentially a bathtub ring from when the lake level was higher. And the landscape, it's a combination of the lake being higher and the landscape rebounding since that lake stage. And so you see the cut there that is left over from that period of time. And when you're up on the bridge, if you look at the Mackinac Island, you can see these cuts very clearly, and they indicate former shorelines. And the dunes up there are different. On these really high bluffs, they're so-called Perch Dunes. The most famous example, of course, is Sleeping Bear. It's not the only one by any stretch, but it's the most famous. And they're called Perch Dunes because they're sitting on high bluffs that are perched above the water. The dunes down in the lower part of Michigan are like those at Holland, where they're right close to the shoreline. The Perch Dunes are elevated high. And most of that sediment that you see there at Sleeping Bear, if you've been there, is glacial, actually. There's a little bit of misinformation up there because everyone tends to think that the whole thing's a sand dune, and it's not. Most of it's glacial sediment. There's a contact in the upper part of that glacial sediment, and that's the boundary stratigraphically, a geological term, stratigraphically between the glacial sediment below and the windblown sediment above. And that windblown sediment is originating from the bluff. Air is striking the bluff face here. The westerlies are striking the bluff face, and then it blows sand up above it to form the dunes. So it's a pretty unique relationship, and it's magnificent. You may remember, some of you, that this part of Michigan was recognized by Good Morning America maybe 8-10 years ago as the most beautiful part of the country that nobody knew about, except us Michiganders. And here you can see the bluff below this that's the glacial sediment on the order of 120 feet thick. This dark zone that you see here is the contact between the glacial sediment and then the windblown sediment above that. And all of that sand that's in the windblown sediment is coming from the bluff itself when the air is moving it from that location. Now, other dunes up there are interesting because whereas the dunes in the southern part of the basin along the southeastern shore front the lake shore for many miles, up north they're more isolated. Like the Perch Dunes are isolated on these bluffs. Other places like Little Traverse Bay, you'll find dunes are at the end of pocket beaches like these. This is at Petoskey State Park. And what's happening here is that longshore currents are flowing. They're moving sand inland or deeper into the bay, where it is then blown up to form these dunes downwind of that. But it's isolated at the head of that embayment. That's different than what we have in the southern end of the basin. So the question that I had when I first started working here, Tyler says I've been here since '95. That doesn't seem remotely possible, but I guess it's true, is what's the age of the dunes? How old are these things? How did they form? And we know the wind blew them, but is there any kind of variability to it? The most kind of best known layperson's book, high level, even sort of a classroom text can be used at times, is The Geology of Michigan by Dora and Neshmann. That was in 1970. And they devoted a whopping 4 pages out of a 270 page text. They developed 4 pages to dunes. And this is from one of those pages. This is representative. And you see this is at Warren Dunes in the southwestern part. It says blowouts due to wind action on shorewood side of old high dunes. I guess high means really tall, related to higher water level of Glacial Lake Nipissing. Well, Glacial Lake Nipissing was about 5,000 years ago, 6,000 to 5,000 years ago, something like that. And it cut some of those notches in the landscape along the shore to the north. Well, the assumption was when I came here that the dunes had formed at that time. That's when they formed. And the logic is that the lake was high. There was a lot of erosion. When the lake fell, there was a lot of sand. The beaches were really, really wide and long, and all of that sand blew up to form these dunes. And on some level, that makes some sense because it's easy to picture that way. But that's not the case. It's much more complicated than that. So if the Nipissing hypothesis is accurate, if it is, then this is the story. What you see at the bottom is calendar years BP. That's calendar years before present. And 0 is modern, that's today. 5,000 is 5,000 calendar years before present. And the curve that you see up above is the lake level curve that's been reconstructed by other people who are much smarter than I am for that 5,000 years. And you can see that the lake was much higher, 15 feet higher than now. Complex reasons for that I won't get into here. And you can see how the lake fell in the aftermath of that. And the thinking is that's when the dunes formed, when all that sand was then available in these big wide beaches for that to blow into dunes. But I'm like, is that really true? And the beautiful thing of it for me, the lucky thing for me, is that the dunes had not been dated. The chronology was not known. It was just assumed. Like a lot of things in science, these paradigms sort of take hold and they stick and until somebody comes along and tests it. This was easy. I had studied dunes in my dissertation in the Great Plains. I talked MSU into giving me a job because these dunes needed to be looked at here, and they were crazy enough to take me up on the idea. And I started looking at the dunes. So what we've done hasn't been me alone by any stretch of the imagination, but I kind of did start it. I will say that. Is there are two ways of dating these things. One is radiocarbon dating. Everybody's heard of that. And basically what you're looking at is you're looking at organics that were buried at some point. You collect them like I'm collecting here, and then you send them off to a lab and they'll give you a date. And then the other is something called optical stimulated luminescence dating. And that is dating the last time, estimating the time that sand grains were last exposed to light. And the assumption is that the last exposure to light was when the sand was last moving in the wind. It was deposited, then it was buried, and then it was encased in darkness ever since. And there's a way of collecting it. I'm pounding into this here, I'm pounding into this face. This dark color you see here is organic matter that we could collect a radiocarbon date from. What I'm pounding in is a tube here to collect sand that's been in the dark. The tube is lined so it will remain in the dark. You send the tube to a lab. There are some tests that they can run on to estimate the last time it was exposed to light, and there you go. So here is, this is representative. We have, at this point, we have over 250 total dates on these dunes, which makes them one of the best developed and studied dune fields in the world. This is at Van Buren State Park, which is in the southwestern part of Lower Michigan, and this will be representative of what we found. Again, I was lucky. Nobody had studied these things. I walked over to the beach. That's our old dog at the time. That's not me, but this is the view that I had. You could see this dark organic layer here. Here's another one there. Whoops, what am I doing here? There's another one above that, another one above that, and another one above that. And right away, that told me that these dunes did not form at one time. It was that simple. And nobody had done it. Lucky me. I had done some of this work in the plains again. And so I'm like, okay. So I asked NSF for some money for dating these things because, you know, a lot of people like them. And lo and behold, I had some money and off I ran, and I built my career off this, luckily. And so what I'm going to show you here is representative stratigraphy of these dunes. The lake sediments that you see below are the Nipissing lake sediments from 6,000, 5,500 years ago, something like that. Formed on top of that, that is a old swamp. or bog, that a wetland, if you will, that was present when Nipissing was really high. You see that on the lake shore today. If you're on the shore, you'll find a wetland not too far inland from where the lake is. Same thing then. And the dark represents the organic matter that accumulated in that wetland. And it's on the order of that thick. You bust it open, it smells, you can smell the methane, and it's carbon. So we dated that, and we dated the bottom and we dated the top, and we know that was a wetland sometime between 6,000 and 5,000 years ago, probably for on the order of 500 years. It's a guess, but it's an educated guess. And then sand accumulated, and then another soil formed. These soils form when sand is no longer being supplied to these dunes. And so organic matter can take root, plants can take root, leaves decay, all of that on a stable surface that is decomposed into organic matter that we can then date. We obtained a date here between 4,400 and 4,000 years ago. This is between 3,700 years ago and 3,300 years ago, and so on up the stack of sediment. That's between 464 and 129 years ago, and so on. Luckily for me, is that all these dates are in the right order. The oldest stuff should be at the bottom, and indeed it is. And it gets progressively younger, and you can literally see how this dune grew upward through time. But it didn't do it all at once. It did it in stages. Sand was supplied, it stopped. Sand was supplied, it stopped, and so on. We think that that is related to lake level fluctuations and climate change in the past. Now, north of the hinge line, that imaginary line where the landscape is rebounding, the dunes did not grow vertically. They grew outward because new, progressively younger shorelines are being uplifted through time because of rebound. That provides a fresh place for sand to accumulate when it blows. Here, we've had to rely mostly on optical dating because there's not much organic carbon up there because the dunes do not grow upward. And what you see here is, this is a date 3,400 to 2,800 years ago. This is the Nipissing Bluff, the Nipissing Terrace, and you'll see that the sands get progressively younger as you go lakeward. This most recent dune is between 1,000 and 720 years ago or something like that. So in the southern part of the basin, the dunes are growing up. In the northern part of the basin, they tend to grow towards the lake because fresh lake is growing upward because of uplift. So what we've done is we've tried to understand, okay, well, what's going on here? How does it relate to lake level fluctuations or anything like that? Prehistoric climate changes. So we've thrown all of our optical dates into a statistical mishmash. Ka is thousands of years ago. So over on the left is 6,000 years ago, and then 2,000 years ago, 1,000, and so on. And when you see a peak like here, there it is. See a peak like there, that is a time when there was a higher probability of sand blowing around. One of the things that's really interesting to us is that from about 2,000 years ago to about 1,000 years ago, the dunes were largely stable. And they were probably stable for on the order of 500-600 years. This peak at 1,000 years ago, that's the medieval climate anomaly, or the medieval warm period, if you want to call it that. That is very well known in Europe culturally. And was a time when sand was blowing around a lot in the Great Plains. Dune fields in the plains date to that period of time. And apparently sand was blowing around in Michigan too. And then this little peak that you see here, that's the Little Ice Age, when it was a lot stormier and just unstable at that time. So what we've concluded is that the dunes have grown mostly during periods of time when the lake was rising in the past, and as the lake was rising, it was pushing sand up onto platforms that then could be blown by the wind, and that the dunes tended to stabilize when the lake fell and the supply of sand was sort of cut off. And that's different from the original model. And there's been a lot of articles published, well over 25 articles published about this stuff. And it's been pretty cool. Now, I'll show you something fun here that we're working on now. What we've done is we've looked at most of the work to this point has been on the prehistoric, say from 6,000 years ago to the present, 3,000 years ago. What's going on? It's really kind of hard to reconstruct that with any sort of really high confidence. So my PhD student right now, Kevin McKeon, for part of his dissertation, he's looking at repeat photography of the dunes, where he's found old photographs from as far back as he can find them, photographs that people took. And then he's gone back to the same location to take the shot again to see if there's any noticeable difference in the dunescape. So we can kind of get some sense of what's going on in the historic, and maybe that can help us inform us about what happened in the past in sort of a uniformitarian geological way. And I'm going to show you, he's done a bunch of this work. I'm going to show you a few of them because it's fun. Now, this work has been done a lot in the Southwest. Obviously, this is not Michigan. There's been a lot of this work in the Southwest. This is in Arizona. And this was a photograph that was taken by William Henry Jackson in 1870. And here was a repeat photograph of the same landscape not that long ago. I actually had undergraduates in a class of mine. Somebody in the back room went, wow, when he saw that. And I nearly retired on the spot because I'd actually reached a kid in lecture. So again, this is then 1870 and now. That's juniper that you see in the foreground. The reason for that is because it's a fire suppression. The U.S. Forest Service is suppressing fire, so juniper's taken over. So very little of that work has been done here in Michigan. So Kevin is working on this for his dissertation to find these old photographs. We found a number of them. You know, we had some citizen scientists send him some, tried to engage the community that way. It's been pretty cool. So here are all the sites that Kevin has done his work. The blue dots all represent places where we have repeat photographs. I'm certainly not going to show all of them today. I'm just going to give you a handful of examples. Here we go. This is at Grand Beach, which is in the southwestern part of Lower Michigan, not that far from Van Buren. This is Grand Beach in 1987. Nice old Chevy in the foreground, trees in the background. Part of Kevin's job is to find the exact spot where that photograph was taken. You know, I can feel John, the historian, going, "Yeah, this is all right, man. This is good stuff." You know, and so he tries to line everything up. You know, how does the road fit with the forest in the background, and try to find the exact spot. It's kind of tough. In the West, it's easy because you can go to that one pinnacle where that person was. Here, it's different because sand moves things around, and so it's harder. But he's still done a pretty good job. So here it is in 87, okay? And here was 2019. I see audible reaction. I guess it's not audible. But 1987, that's not that long ago, and 2019. That's pretty cool, isn't it? Here's another one. And you can see the tree line in the background. This one here. That's what he's using as his guide in this intersection, which, you know, apparently is here. You know, he did the best he could, and that's pretty close. All right. This is Warren Dunes in 1900. For one thing, one of the things about this shot is that it makes you realize what people were willing to wear to the beach in 1900. You don't see that today. But there's Warren Dunes in 1900. And again, you're trying to line things up. You know, how does this tree line here work? You know, is there anything here that you can go, okay, all right, I see where that's at in my field of view and so on. So there it is 1900, and there it is today, 2019. So again, 1900, 2019. Saugatuck, Oval Beach. It's a primo beach. It's fed every year. So, you know, there's always going to be a beach there. This is in 1947 at Oval Beach. Look where this was taken. I was with Day, and I feel really good about this location. Again, you're trying to look at the arc of the shore here and how that all fits together in your field of view. This is Saugatuck in 1947. You can see that the bluff is high angle. I guess that'd be a way of putting it. 1947. There it is today. In 2019, again, 47, 2019. And obviously the bluff angle is much reduced. There's a lot more vegetation. It's a very different place. And it's grown upward. Here's Lake Town Beach, 1989. Same thing applies. There's Lake Town Beach in 2019. Again, 89, 19. Trees in 30 years. Kevin's really excited about that. Holland State Park, 58. My birth year, 1958. And there it is today. Very different landscape. This is this gigantic development is now there, and Kevin's fired up about that. True, more trees. Silver Creek, it's about halfway up the peninsula. Here's Silver Creek in 1915. I love this shot. 1915 and today. So very, very different. And then Sleeping Bear, the famous Sleeping Bear dune climb, 1917. Finding the pictures was half the fun. Sleeping Bear dune climb, 1917. Maybe some of you have taken this. There it is today, 2019. Even with all those people climbing this thing on a regular basis, it's a lot more vegetated. And then this one might be my favorite one coming up. This is North Manitou Island. Kevin went out there, hired a boat. I paid for it. Out he goes. The Crescent Dock area in 1905. This was a logging era, and that dock was used for that, to haul logs off. Crescent Dock area 1905, and there it is today. So pretty cool stuff. And what he's able to demonstrate is that there's been a lot of expansion of plants across these dune faces in the last century. It's probably related to gradually more precipitation, which is just causing the dunes to gradually stabilize. So that tells us something about how these things are responding. It's pretty fun. Hopefully we can use it to apply to the past as well. And with that, I think I am done. In fact, I know I hope I met the mark on time.
Oh, that was just about perfect, actually. I want to give a round of applause to Dr. Arbogast.
I want to hear
virtually
it.
Or
hey, my wife's in the other room. I heard that.
That's good. That's good. So, Dr. Arbogast, if you could stop sharing your screen so we could all see each other. And then we already got the first question in the chat, so we're off to a running start. And so Pete wanted to know if he asked the question, did water from what we now call Lake Michigan flow out towards the ocean through a course in the center of the state of present day, Grand Ledge, and erode the ledges? Did any dunes form what were now inland areas of the state?
That's a good question. There are actually dunes in the interior of the state. I've studied those as well. There's a variety of really nice dune fields. There's one just south of Houghton Lake, just as you enter Roscommon County. As you're driving 127 north, as you cross the Roscommon County line, you drive through some dunes, a highway cut it through some dunes. They're not like the Lake Michigan dunes in that they're not gigantic things, but they formed as the Ice Age was waning. And as the ice left, it left behind a lot of sand. These are not coastal dunes. They're like the dunes in the Great Plains, really, in that sense. And as the ice retreated, it was very dry and windy at that time, and dunes formed, and they're all over. The Saginaw Lake Plain up by Midland is covered with sand dunes. They're small, but they're definitely dunes. As far as water flowing across to the east at a high lake phase to like a Road Grand Ledge, no, but there was a period during the last deglaciation of Michigan about 14,000 years ago when catastrophic discharges from what's now Saginaw Bay blasted across the peninsula of Michigan at the Maple River Valley. If you drive north on 127, there's a huge wetland up there, right at the Maple River. It's north of St. John's, about 5 miles, something like that. Huge wetland. That is a catastrophic outburst channel from when water flowed across from east to west.
Excellent question. The next question is from Carol. She asks, given what you've learned about the development of Michigan coastal dunes over the last century, what would you predict for them in the coming century?
That's a really good question. And it has a lot to do with how the people of Michigan choose to manage them. I have spoken to a lot of groups, and one of the passions that people have about Michigan's dunes, and there's a lot of people out there that are passionate about Michigan's dunes, is sand mining. And they are mined pretty heavily for sand in some places. And those mines can be ugly and loud, and they have destroyed some dunes. But that said, my biggest concern over the next century is the drip, drip, drip of development within them. The state of Michigan has in their language about the dunes to preserve the diversity and quality and function of the dunes. And that means that sand's going to blow around. People don't like that. I mean, they do, but they don't want sand blowing and burying their deck or their driveway. And so there's a lot of pressure on the dunes for that reason. That people plant vegetation. I don't think that has much to do with the expansion plants that we've seen in the last century. But they're being developed more and more and more and more. And at some point in time, they're going to become sort of a fossilized landscape. The form will be there. There's just not going to be as much active sand blowing around. And that is probably the biggest challenge for the next century.
Excellent question, Carol. The next question is from David. So David, references the massive harvest of forest in Michigan during the late 19th century. And so he asked, could the lack of trees in the old photographs have anything to do with, the massive deforestation that Michigan saw during the late 19th century? And could the change be related to, more of a willingness for people to let the forest grow?
David, right? Is that right? Yeah, you are preaching to the choir. I love that. I love that question. I wish Kevin, my student, could hear you or see you or read the chat of you asking that question, because students have a tendency to, as we all do as scientists, the challenge that we all face is sometimes you feel like you're going down this rabbit hole and that's the right one. But other things could be involved. And I have certainly prodded him to think about that. And I think at the very least, I'm like, Kevin, you have got to show, maybe not everywhere, but at least somewhere, you've got to show that that wasn't a factor. If you're going to throw your anchor on precip. Now, I think he's right, but he still has to prove it and defend it. The one thing I'll say about that is that we don't have any record. He has looked and cannot find any record of hardcore logging of those dunes. Moreover, if there was, there would be stumps. And there are many, 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 many places in Michigan where you can see cut stumps and from that cut. And I have never, and I've been through a lot, I have never encountered one. It's not to say it's not there, It could be buried, but if it was buried someplace, it would have been exposed someplace else. So but that's a very good question. Very good question.
Thank you, David. That was really good. So our next question is from Jim Blair. So I'll go ahead and let him ask that.
Yes, Al. We have a place up in Leland, and what we've tried to figure out is there is a series of dunes that start east of Lake Leelanau,
Yep.
run to Sutton's Bay. And it's a set of rolling, very steep, very tall, really sandy, don't seem to have a lot of sediment in it from the glaciers. How did those form? Those dunes that are east of Lake Leelanau towards Sutton's Bay.
I geographically, I know where you're talking about. I've been to Sutton's Bay a few times. I have not actually looked at those dunes specifically. Are they elevated on any kind of bluff? On the big lake side?
I would say no. I'm just guessing, but there's a lot of mining going on because the sand is so pure, and there's not sediment. There's not a lot of sediment in it. And they're very steep, and they roll.
Yep.
There's valleys in between because that's the way those crazy roads are up there, because we have to drive around them to drive to Traverse City. But I've always tried to figure out. I can figure out how, and you've explained how they developed along the lake, but this is inland 10 miles. Well, not 10 miles, 5 to 8 miles.
Well, it's possible. It's possible that they are residual from what would be Glacial Lake Algonquin. Glacial Lake Algonquin was a very, very high lake stage of about 12,000 years ago. Ice was draped across the UP, southern Lake Superior at that time. So in your mind's eye, if you, like from Sault Ste. Marie over to the Keweenaw, if you imagine that, and that's where the ice margin was. And there was so much meltwater coming off of there, and the landscape was so depressed isostatically that the upland there that you're talking about, where those dunes are, would have actually been lakeshore property at that time. And it's possible that there were dunes that formed. I need to go take a look at these things, because it's possible that there were dunes that formed at that time that are from that era. And if that's true, then that is worth knowing by a long shot. I have to check that out.
Excellent question, Jim. So the next question is from Barbara. She asked, what were your thoughts about the current catastrophic erosion near Muskegon, Whitehall, and things in those areas?
I'm not surprised. Lakes at a near all-time high. The last lake stage of a similar magnitude was in the mid-'80s, 1986, and there was similar erosion. It's the nature of things. That's how the lakeshore evolves in the big picture. We have we use that. I mean, I know it's a horrible thing for the people that live over there and what's going on. And we have friends of our own, Jen and I, we have friends of our own who are quite concerned about that at New Buffalo. But it was an opportunity for us in geography, because we made a pitch for a coastal geomorphologist. I'm a dune geomorphologist who happens to work on the coast. We made a pitch for a coastal geomorphologist, somebody who's actually working on coastal things like erosion, sediment transport along the shore and whatnot. And Ethan Tierkoff got the job. He's a great fit. And he and another couple of other people who are working at, I mean, there's grant money to be had there. They just submitted a proposal for $9 million out of the federal government for that very issue. The review process hasn't even begun yet, but I'm encouraged.
Really good question, Barbara. And so Susan made a comment about she had a cottage on Lake Michigan near Cross Village. They had a very large dune nearby. And she remarked that there didn't seem to be any change in size or vegetation. And then Barbara had a question. And so she was talking about, assuming in her place near the lake, that they planted some white pine saplings back in the 70s, and they've had far less erosion than their neighbors have. And they also installed some jetties and groins instead of seawalls to preserve their dunes. And so she just asked you kind of any thoughts on any of that.
Well, to think about dune geomorphology in kind of a holistic way, it's the interaction between sand, wind, and plants. Plants hold them together. The root systems, they're the glue that holds dunes together. And in the UK, John probably knows more about this than I do, but in the UK, back in the 70s, and before that maybe even, because there's some great research that's been done on sand blows, coastal sand blows in medieval UK that were burying coastal communities. And in response to that, and then later on, there was a massive campaign to plant dune grass, marram grass, in sand dunes in the UK to stabilize them. And it makes some sense. In the recent past in the UK, the effort has been to tear that grass back out so dunes can behave naturally and do what little dunes do, which is move around. Here in Michigan, we've sort of taken an alternative approach, which is largely to stabilize them. Planting white pine would be a less invasive way of doing it than jetties and all of that other stuff. But it's a constant struggle over there, and one that I think people in the state are going to deal with more and more as time goes on. Boy, a lot of questions. Good questions.
Thank you for that remark, Barbara. So, Carol, you had a question. What happened to Singapore? I was wondering if you could perhaps elaborate on that, more specifically what you're asking.
I'm not referring to the place in South Asia. There was a place in Michigan called Singapore.
Hi, Carol. How you doing? I'm familiar with that. It's an interesting story. It was a logging town that had dreams of being the next Chicago, and it's near where Saugatuck is now. And they had a little thing going. Is back in like in the late 1830s or something like that. And they had a little thing going. And then there was the Chicago fire. And there were actually a number of large fires in the Midwest at that time. Chicago fire was the worst one. And to rebuild Chicago and Milwaukee and other places, that's when the Michigan logging boom really took off. And all the trees around Singapore were logged, and the sand started to blow, and it buried the community. Now, the town was already failing, my understanding is. And in fact, people were beginning to relocate to Saugatuck because geographically it was a better place. But that's the blowing sand was the death knell for sure. I mean, they were on their way down, but that was the thing that was like, okay, it's over.
Excellent question, Carol. That definitely taught me something. Next question from Dr. Waller, so I'll let him ask that one.
Dr. Waller. Okay, I gotta make sure I'm geared up for this.
Thank you, Alan. That's really interesting. My question though is more about what's to the side of the dunes, and that's the lake. Given that there was about a mile high body of ice sitting on top of Michigan, is my understanding, during the peak of the Ice Age. Why do you have it? I don't know much about the depth of the lake, but it's quite substantial. How did when did the lakes form, and what was it that meant that you could have the landmass and then a very significant depth adjacent to it?
Yeah, well, that's a great question. I mean, it's a testament really to the power of ice, one, and variations in rock resistance. You know, I'm thinking of this map that I have from another lecture about the Ice Age in Michigan, and that very thing, pre-glacial, and we think of the glacial epochs beginning at about 2 million years ago during what's called the Quaternary and the Pleistocene specifically. Pre-glacial, where you in your mind's eye. If you think about where the Great Lakes are, okay, and the orientation of the lakes and whatnot, the lakes were river valleys. So if you think about Lake Michigan's the easiest one because, okay, here's Lower Michigan there, Lake Michigan's here. This was a river valley. There was a river here that I mean, we're talking, 3, 4, 5 million years ago. Another one in Saginaw Bay and so on. They weren't giant river valleys, but they were cut into soft rock. The nature of the geology of Michigan is that Michigan is a depositional basin. So in cross section, if you go from from Saginaw Bay here to Lake Michigan there, okay, you following? If you look at that cross section, the bedrock geology goes like this, like a basin, okay? It's like a cup. The softest rock is on the edges. So what happened was as the ice advanced into these river valleys that were in the softest rock, it slowly enlarged them. And then every time the ice retreated and then re-advanced, it went into the valley again first, because that's where the lowest part was, and it would enlarge them. And so Lake Michigan and the other Great Lakes, and Lake Michigan is easy to visualize, is the modern legacy of that process happening 25 times. So it enlarged that river valley into this giant lake. Now, what's under Michigan, the peninsula of Michigan, is the hard rock. That's the relatively hard rock. So the ice preferentially eroded the softer rock around, which is what created the lakes, and the relatively harder rock was left behind, forming the peninsulas. And you can really, when you think about the Leelanau Peninsula, we talked about that, the Leelanau, the Keweenaw, the dot of islands that goes across from the UP into Lake Ontario or Lake Huron, those are all hard rock. That's the hardest rock. And so that's why it's still there. I don't know if that, that's kind of hard to do, with my hand and all that, but I think I got it. I need a meat pie for that.
Another really good question. So next question is from Marianne. She asked, have there ever been any storms or as vicious as a hurricane in the Great Lakes region that could potentially drastically change the dunes on the coastline, as you might see in a place like Cape Cod or along the coast where, the hurricane can come in and wipe out an entire dune field overnight?
Well, we're thinking about that actually, because one of the things that Kevin is looking at is the geography of blowouts. Blowouts are big depressions in the dunes. They're big bowls where there's bare sand exposed. Perhaps you've seen them when you're hiking over there. And we're looking at, we have our first air photos of that landscape are 1938. And there's a slew of blowouts up and down the lakeshore. And you can see them clearly because on the air photo, they're bare sand, whereas everything else around it is dark. That's vegetation. Well, Kevin's starting to look at, do we still have the same blowouts now that we had then? And the answer seems to be yes. That, in fact, what's happening in those blowouts is that they're healing, vegetation is expanding in them. And something happened pre-1938, apparently, that caused those things to form. That hasn't happened since, which is really interesting. If you just think about the power of Michigan storms, the storm that sunk the Edmund Fitzgerald, that famous storm, reached 100 miles an hour. I mean, that's low-level hurricane there. So imagine something like that hitting the lakeshore now, and that would be, especially at a high lake phase that we're in right now, that would be very, very dramatic. Fascinating, but for a lot of people, probably not all that pretty.
Always a really good questions. This has been a good session. I actually had a question. It's a little bit of a political one. So obviously these dunes are a major source of economic revenue, especially for coastal towns in Michigan. And so if anything would threaten to, the security of the dunes, that'd be fairly catastrophic for a lot of the western portion of the state. So, like, do you think the state of Michigan should be doing more to protect the dunes? Is there anything they can be doing more to protect the dunes?
Well, whippersnapper, you've you've walked into a hornet's nest there. Yeah, I mean, in the state statute, it says we're going to do everything we can to preserve the diversity, quality, and function of Michigan sand dunes. If they all wind up stable one of these days, then that will be lost. But the question is how do you do that? I mean, there is a lot of economic power over there. There's a lot of, folks are generally leery about government stepping in and saying, hey, wait a minute, don't do that. So, I mean, it's a good question, and it's a bit of a hornet's nest. I've dabbled in that a little bit, people have tried to draw me into it big time. I'm just trying to understand their history and then kind of let the state go where it will and see where things go. How's that?
Very, very good response.
Well, I'm going to address it a little bit. This is my last year as chair in the department, and I'm going to start next fall. I'm going to start my new book with MSU Press about Michigan sand dunes, and I got a chapter on that. So I'm going to wait till the movie.
Is that just a shameless plug for your book?
That was a shameless plug. Yeah,
All right,
2 years in advance.
I'll be watching out for it. Don't worry.
Sure. How long does it take to write a book, John? Oh, sorry.
That was a low blowout.
All right. Anything else? I had fun.
Is there any final questions? Anything else? Anyone else have anything to add? All right. Yeah. No, this was a very good session. So
Tyler,
I'd like to.
was the last question asked? I wasn't sure.
Yeah, Barbara made a comment just about, like perhaps we shouldn't delude ourselves into thinking that we can control the dunes and they're just part of the diversity. So They're good comments. I appreciated it.
Yep.
Now, this is a really good session. These were all excellent questions. And so I would just like to thank Dr. Arbogast for taking this time to meet with us again today. So, and I'd like to thank all of you for coming and participating. And please continue to sign up and come to these town and gown sessions. You know, your participation is vital, and we really appreciate having you. So,
I want to thank everybody for attending. It was a lot of fun, and I mean, I can always tell when people are interested about this landscape. It's fun to talk about. I left a faculty meeting at 4 o'clock, and trust me, this was a lot more fun than that was. So this was my carrot. Thank you.
Thank you, Alan. Thank you, Tyler.
Here in Atlantic Canada,
Yeah.
it's wine time.
It's wine time. It's
What a nice way to spend it.
yes, it's just after
Yeah.
6 o'clock.
You have the right idea.
5 o'clock on Friday night, which is 6
Yeah.
o'clock in Atlantic Canada. Are
Yeah.
you kidding me?
Yeah.
Although we look at the rugged coast of Maine from our house on the Canadian side.
And pine for my dunes on the west coast of Michigan.
Yes.
Very cool. Very cool.
Have a good weekend.
Yeah. You too. Take care.
Stay well.
Good night all. Thank you.